Hello, today is Sunday, March 3rd. We just passed March 1st, which is our National Independence Day. So we march first, then we are on March 3rd. 33. 33 means a lot in Korea. It means Samgyeopsal Day. It's pork roasting day. Many people went to a restaurant or had a barbecue outside the city, I think. But I didn't have any of the meat. I just try to stay away from meat as much as possible. Even though I like meat, I try to be on the vegetarian diet. As with other days, let's delve more into solar system. My company, KT Korea Telecom, is into the solar energy business. One time we built solar rooftops, we installed the solar power plants. Now we don't, but now we are doing what we call a PPA, a brokerage system, or aggregator, or broker, or what's the other term? Brokerage, aggregation, or middleman, right? So we need to learn various terms and words that are used in the solar power plant. So the terminology is quite important to us because we need to sell many products and services to customers as a KT man. I'm very proud of my company, KT Korea Telecom, number one carrier in Korea, but I have to retire in 4.5 years from now, and I want to be more knowledgeable on my on our subject field. So that's why here I am. If you do have a good job opportunity for me, don't hesitate. I'm all ears, man. So, by the way, I am trying to read this article to practice English by selecting and reading an English article of 20 to 30 minutes worth of my time to finish that thing up. So it's a purely academic effort on my part. This article is from research, cbinsights.com, and research about research. They researched about solar power plant and solar energy. Solar 101. 101 means the very basic course in that subject matter. For example, calculus 101, calculus 201, or calculus 102. That's the common terminology that universities use in describing the order or attitude or the level of the subject or course for the students. So it's a pretty basic one. Solar 101. From net metering to power purchase agreements, we explain the what of the solar industry. So we explain the what's what of the solar industry. What's what? Let's remember the expression. We explain the what's what of the solar industry. We explain the what's what of the solar industry. This article was prepared February 1st, 2018, Energy ESG. We break down the key terms within the solar industry from upstream and downstream to utility regulations and panel materials. Solar is once again on the table for investors. The price of solar is steadily dropping. By 2021, solar will be cheaper than coal in China, India, Mexico, the UK, and Brazil, according to Bloomberg New Energy Finance. However, solar energy continues to face regulatory headwinds In the US, for example, President Trump recently enacted tariffs on imported solar panels, which could lead to an industry slowdown. For now, though, the increasingly attractive economics of solar energy seem to be outweighing the uncertainties. To provide a better understanding of the industry, we've put together this explainer, right? However, for now, though, the increasingly attractive economics of solar energy seem to be outweighing the uncertainties. To provide a better understanding of the industry, we've put together this explainer. The solar industry is capital intensive, technical, and encompasses everything from utility energy agreements to installing large-scale solar projects. Below, we define some of the most common and often confusing aspects of the industry: the solar value chain, financing and metering, solar thermal versus solar photovoltaics, types of systems, general solar terminology. So it's quite an encompassing basic industry knowledge and terminology. So it is Solar 101, right? It's quite capital intensive. The solar value chain. Upstream solar. Upstream solar describes the segment of the industry that manufactures solar products. This includes the research and development arms of major companies as well as their distribution arms. In 2016, and solar company First Solar reportedly passed $1 billion in R&D spending on its manufacturing arm. Historically, upstream solar has been capital intensive because of high manufacturing and installation costs. However, thanks to price wars across the globe, manufacturing costs for solar have gone down drastically. In turn, upstream companies have become cheaper to run. Downstream solar. Downstream solar includes companies that install solar technologies, finance them, and distribute the product to consumers. So I guess KT was once a downstream solar company. This includes solar financing companies, solar monitoring companies, we are both, and those that maintain solar technologies at utilities. This part of solar is largely service-oriented, yes, KT, and often less high-tech than the upstream segment indeed. As the price war for solar technology continues, many upstream companies have struggled to remain profitable. On the other hand, downstream solar companies have thrived off the increasing affordability of solar technologies. So my company has thrived off the increasing affordability of solar technologies. Increasing affordability. Financing and metering. Net metering allows homeowners with solar panels to send extra energy they've produced to a grid where it can be stored. They can then pull energy from it when needed, or sell the energy to others in their community who are also connected to the grid. Utility companies pay the solar producer retail price for returning this energy to customers, which is often priced significantly higher than if these companies were to purchase this energy independently. Known as a feed-in tariff (FIT), they are required to pay back customers for any electricity that's been fed back to the grid but has gone unused. These policies are aimed at ensuring solar uptake. Let me read these one more time. Utility companies pay the solar producer retail price, returning this energy to customers, which is often priced significantly higher than if these companies were to purchase this energy independently. What the fuck? Known as a feed-in tariff, FIT, they are required to pay back customers for any electricity that's been fed back to the grid but has gone unused. These policies are aimed at ensuring solar uptake. Let me stop and read one more time. Utility companies pay, however, in order to keep service reliable and consistent, non-solar customers also end up shouldering parts of the cost. These rates also include the cost of planning, building, and maintaining the electrical grid. This financing model has created controversy. Many complain that despite not using solar energy, they are still required to opt into the system. It's also put pressure on utility companies. If a significant amount of solar energy is produced, utility companies must juggle between paying high rates to buy back electricity and increasing prices for all of their customers. As of 2017, 43 American states, including Washington, D.C., have policies for net metering. Among the states that have no net metering policies in place are Texas and Alabama. The issue remains contentious in many states. As of November 15, 2017, the Rocky Mountain Power Territory in the state of Utah stopped allowing retail rate net metering. Gross metering. Net metering. What is net metering, man? Gross metering. Unlike net metering, which only sends a certain portion of energy to the grid, gross metering sends all of the solar energy produced in a home directly to a shared grid. Okay, so it's a full or partial, right? If it's a partial, it is called net metering, and if it's a full sale of electricity to the grid, it means gross metering. From there, residents pay for the energy that they take back from the grid, usually at a price that's lower than what they've sold it for. From there, residents pay for the electricity energy that they take back from the grid, usually at a price that's lower than what they've sold it for. While solar feed-in tariff rates for gross metering were once very high, in order to encourage the usage of solar energy, these numbers have since dropped. Net metering's setup, where utility companies buy back electricity at high prices, has ended up being more profitable for individuals. In net metering, each solar energy producing home theoretically acts as its own self-sufficient, independent electricity company, creating, using, and selling its own power. Power purchase agreement, PPA. In a PPA, a solar company pays to install and maintain a solar system at a residence or business. Instead of paying a utility, customers pay the company that develops, designs, and permits the solar energy system. These companies generally charge lower prices than local utilities retail rate. Instead of paying a utility, customers pay the company that develops, designs, and permits the solar energy system. These companies generally charge lower prices than a local utilities retail rate. Front of the meter. Front of the meter refers to energy storage technology that is installed to work with utilities and electric grid operators to meet supply and demand for the grid as well as maintain voltages. Behind the meter. Behind the meter systems produce energy that's intended to be used in the home office or some other commercial facility. These are often net metered, right? Net is quite logical, right? Behind the meter, front of the meter, front of the meter, behind the meter. Solar thermal versus solar photovoltaics. Yeah, my colleague said, what is a photovoltaics or PV? I will explain here now. There are two main types of technologies associated with solar energy: solar thermal and solar photovoltaics. Solar thermal collects sunlight, converts it into heat, and stores it. When needed, this energy is converted into electricity. Two types of solar thermal systems are passive and active solar systems. Passive solar systems use solar thermal energy to control a building's temperature without the use of specific solar technology such as solar panels. One method used by passive systems is direct gain, which refers to the direct sunlight that enters a building via windows and is then stored in floors or walls. Thermal energy stored in floors or walls is known as building's thermal mass. It is the material that captures sunlight throughout the day and releases it through the night. Examples of this material include adobe, brick, concrete, and stone. Materials with higher density can store more heat. The direct sunlight hitting the building is controlled by angling and designing windows, walls, and floors to better collect thermal energy, thermal mass. Depending on how much heat a building wants to store, increasing or decreasing the area that windows occupy in a building is one method of controlling this direct sunlight. Another is how a window is positioned. These systems only start operating once a certain amount of energy has been built up. While they may help reduce the size of an energy bill, these systems aren't full overhauls into solar power. These systems aren't full overhauls into the solar power. Historically, passive solar systems have been popular with houses built out of stone and clay in order to retain heat and stay warm after dark. Built out of stone and clay in order to retain heat and stay warm after dark. After dark, right? Stay warm after dark. Stay warm after dark. That's good word. Stay or expression. Stay warm after dark. Yeah, I'm using Galaxy S24 Ultra. Yeah, I'm rich, so I can afford to buy. 我可以买东西 right? 我可以 Historically, right, it's a passive, full overhauls into the solar system. Active solar systems are solar thermal systems made up of equipment that can adjust efficiency, store energy, and run sensors and pumps. They convert the sun's irradiance or the sun's rays into electricity that then moves air or a liquid through a solar collector. Then they distribute heat through the building. They convert the sun's irradiance or the sun's rays into electricity that then moves air or a liquid through a solar collector. Then they distribute heat through a building. These systems use comparatively small amounts of energy to harvest a lot of heat. So active solar system, I thought they just use a natural convection system without any need for electricity. But obviously they use electricity which is generated from the irradiance or solar rays. And also solar rays heat the liquid inside the thermal system, and it's called active solar system. Solar voltaics, PV, unlike solar thermal systems, use photovoltaic technology to capture sun rays and immediately convert the sunlight into electricity. This is the technology associated with the solar panels. The difference between the two types of energy is that solar thermal uses sunlight either directly or as a source of heat. On the other hand, photovoltaics convert sunlight into electricity. Without added options like storage or other power generation mechanisms, solar photovoltaics only work when the sun is shining, which is why the systems of solar panels are increasingly paired with other power storage technology. At its essence, photovoltaic energy is made up of photovoltaic cells, which absorb light to create an electrical charge. At its essence, photovoltaic cells. Photovoltaic cells are the building blocks of panel-based solar systems. The cells are made up of thin layers of semiconducting material, usually silicon. Light that is absorbed by this semiconducting material creates an electrical charge. By using metal contacts, this charge is then conducted away as a direct current from a solar cell to a PV system. Solar cell, solar module, solar panel, solar array, electricity meter, AC isolator, fuse box, inverter, battery, charge controller, generation meter, DC isolator, cabling, mounting, tracking system. Source, Wikipedia. Right, there's a single crystal, multiple crystal. Solar module. When several photovoltaic cells are put together into a package, they form a module. Solar panel. A solar panel is an arrangement of solar modules. Array. Stacked modules are then arranged as arrays. Arrays are placed on roofs and can power everything from houses to entire grids that support utilities. Right? Solar array, solar panel, solar module, solar cell, module, array, a solar panel, and array. Stacked modules are then arranged as arrays. Arrays are placed on roofs and can power everything from houses to entire grids that support utilities. According to the National Renewable Energy Laboratory, the average home requires between 10 to 20 solar panels to provide enough electricity to power itself. 10 to 20. Monocrystalline solar cells, that's what I was talking about, and polycrystalline solar cells. Monocrystalline solar cells, polycrystalline solar cells. Monocrystalline solar cells. Monocrystalline solar cells are a type of cell used in a solar panel. They are made by rotating a single silicon crystal that it is slowly removed from liquid molten silicon. Monocrystalline-based cells have high efficiency rates and take up less space than other solar products, which makes them popular among consumers with limited space. However, they are also the most expensive type of solar panel and are easily affected by dirt, snow, and temperature shifts. Monocrystalline solar panels. They are made by rotating a single silicon crystal as it is slowly removed from liquid molten silicon. Liquid molten silicon is just rolled, it's rotating, right? Polycrystalline solar cells, also known as multicrystalline, polycrystalline cells, right? Multicrystalline or polycrystalline cells are made of multiple crystals instead of just one. Polycrystalline cells are cheaper, easier, and less wasteful to produce than monocrystalline cells. However, because these cells are structurally inconsistent in the places where cells meet, they are less efficient at harnessing solar energy. They are ideal for solar installations with no constraints on space and of those looking to save on upfront installation costs. Because these cells are structurally inconsistent in the places where cells meet, they are less efficient at harnessing solar energy. Thin film amorphous PV cells. Thin film cells make up panels that are thinner and cheaper to buy than conventional solar panels. They have solar cells with light-absorbing layers that are nearly 350 times smaller than that of a regular silicon panel. They are the lightest PV cell on the market that manage to retain durability. However, they are not very efficient. Ooh, really? I think Elon Musk is developing thin film PV cells. They are nearly 350 times smaller than that of regular silicon panel. Thinner and cheaper to buy, but they are not very efficient. Solar thermal photovoltaic cells, TPV, right? Solar thermal photovoltaic cells. Solar TPV cells directly convert heat energy to electricity with the use of photons, the elementary particles that hold light. They contain multiple layers, one of which is a carbon nanotube absorber that can take in a large portion of the sun's spectrum and then convert it into heat. That's good. It can just take in a large portion of sun's spectrum and then convert it into heat. solar thermal photovoltaic cells. While PVs can only convert a small portion of sunlight's energy spectrum into electricity, TPVs have access to a much wider part of it, making them highly efficient. Solar thermal photovoltaic, so TPV, right? TPV, solar photovoltaic, TPV. Multi-junction solar cells. These cells achieve some of the highest levels of efficiency among solar cells, with one reaching a 44.5% conversion rate of energy that hits it. They do this by stacking multiple layers of solar hardware into a solar cell. Each of these layers absorbs a different portion of the solar spectrum, opening up more capacity, right? Multi-junction solar cells, opening up more capacity. That's good expression. That's hyphen. Junction solar cells is taking up, opening up more capacity. Maximum power point tracking, MPPT controller. An MPPT converts higher voltage direct current outputs from solar panels into the lower voltage DC that's used for charging batteries. Maximum power point tracking, MPPT controller. An MPPT converts higher voltage direct current outputs from solar panels into the lower voltage DC that's used for charging batteries. By comparing the output of the panels to the voltage of the battery, the system figures out the ideal amount of power that a panel can put out to charge the battery. Grid-tie systems described below, which are grid-connected solar electric systems that create their own electricity and save what's left over into the utility grid, generally have built-in MPPT controllers, right? Grid-tie systems are described below, which are grid-connected solar electric systems that create their own electricity and save what's left over into the utility grid, generally have built-in MPPT controllers. So it's like a cross netting. Parallel connections. Parallel connections or circuits occur when the positive terminals of all the solar panels are connected and negative terminals of all the solar panels are connected. It's a parallel, right? The panels wires are then connected to a centralized wire that leads from the roof. These types of circuits are usually used in small basic systems. Series connections or circuits are created when the positive terminal of the first solar panel is connected to the negative thermal of the next one. Each panel is connected to the next in what's known as a string. All of the distinct voltages of the panels are added together, but the amps that measure electrical current remain the same. Most grid-connected homes use series connections for their panels. Because the current remains the same in series connections, they require less wires, which can bring down the cost and effort of installation. Series connectors are often used in smaller systems along with an MPPT controller. Since MPPT controllers can convert high voltage solar panel outputs into lower voltage DC needed to charge batteries, they can connect to a system with high outputs and continue to charge batteries. One downside of series connections is that if a single panel goes out or is shaded from sunlight, it can decrease overall production significantly. Damn. Yeah, so it gotta be a small scale home solar panel power plant. Series parallel connections. These use a combination of the two and are often used for larger systems in order to remain within amperage and voltage parameters. Amperage and voltage parameters. So MPPT, right? MPPT, series connections, parallel connections, MPPT. A maximum power point tracking system. Types of systems: grid connected, off-grid system, hybrid system, peaking power plants, concentrator photovoltaics, concentrating solar power, right? There are several terms. Types of systems: grid connected, also known as grid-tied system. A grid-connected solar electrical system creates its own electricity and saves what's left over into the utility grid. Grid-tied system, right? Known as a grid-tied system, a grid-connected solar electrical system creates its own electricity and saves what's left over into the utility grid. Off-grid system. An off-grid system, also known as a standalone system, creates energy and then stores it in batteries for later usage. Off-grid systems are not connected to the utility grid. Off-grid system or a standalone system. Off-grid system, grid connected. Hybrid system. Hybrid systems combine solar energy with other energy sources. Hybrid system. Peaking power plants, also known as peakers. These power plants only run when there is a high or peak demand for electricity. They are usually gas turbines that burn natural gas. These peak times can be at night or even during a natural disaster. Since energy is only taken occasionally from peakers, it's charged at a much higher rate. Peaking power plants, right? Peaking power plants, peakers. Peakers. They use natural gas because you need to store gas for emergency operation, right? Peakers, known as peakers, peaking power plants, peakers. Concentrator photovoltaics, CPV. CPV systems use carefully angled mirrors and lenses to direct sunlight into a single beam that is then reflected onto the small surface area of a solar cell. This allows for usage of small, high-performance solar cells. These cells can also be moved throughout the day to angles that expose them to the greatest amount of sunlight. CPVs, concentrator photovoltaics, right? CPVs can only convert direct sunlight into energy, meaning that they are inefficient with a significant portion of sunlight that shines through clouds or the atmosphere. CPVs work best in areas that have high amounts of direct normal irradiance, including the United States, Sun Belt region, and Southern Europe's golden banana. Southern Europe's golden banana, right? Sun Belt region, U.S. Sun Belt region. I am interested that sunlight belt region, quality, quantity, number of the states that fall under the region, and Southern Europe's golden banana, CPVs, concentrator photovoltaics. CPV systems use carefully angled mirrors and lenses to direct the sunlight into a single beam that is then reflected onto the small surface area of a solar cell. This allows for usage of a small high-performance solar cell. Concentrator photovoltaics, CPVs. Concentrating solar power, CSP. Similarly to CPVs, CSP systems use mirrors and lenses to concentrate large swaths of sunlight into small areas. However, when the concentrated sunlight is converted into heat, it's used to power a heat engine, like a steam turbine that is connected to a power generator. Unlike CPVs, these plants are made up of two parts, one that turns solar energy into heat and another that turns that heat into electricity. CSPs can produce large amounts of solar energy, which makes them useful for utility scale projects. Utility scale projects. In September 2017, Dubai Electricity and Water Authority (DEWA) awarded China's Shanghai Electric and Saudi Arabia's ACWA Power with the world's largest single-site CSP project. The project is the fourth phase of the Mohammed bin Rashid Al Maktoum Solar Park, which is located about 50 kilometers south of Dubai. The park anticipates producing 1,000 megawatt or 1 gigawatt by 2020 and 5,000 megawatts by 2030. So CSP, concentrating power, solar power, right? It's a similar. It uses mirrors and lenses, but instead of generating solar energy, solar electricity directly from the sunlight, it uses a steam turbine to rotate the generator that produces electricity, right? Similarly to CPVs, CSP systems use mirrors and lenses to concentrate large swaths of sunlight into small areas. However, when the concentrated sunlight is converted into heat, it is used to power a heat engine like a steam turbine that is connected to a power generator. General solar terminology, watt. A watt, W, is the rate of energy transfer under the electrical pressure of 1 volt. Solar energy is generally measured in kilowatts. 1 kilowatt, right? 1 watt is 1 volt multiplied by amperage. Watt hours or kilowatts. Watt hours, WH, or as they are generally known in cases with large amounts of energy, kilowatt hours, kWh, right? Watt hours, kilowatt hours are used to measure the total amount of energy produced over time. Capacity. Capacity typically refers to opening up the capacity, right? Capacity typically refers to the optimal output of a solar system. This is measured in watts or kilowatts. It can also refer to the size of a system. Capacity. Load. This is the amount of energy that an electrical device or unit uses at a given time. that looks like a solar CSP, right? Solar concentrating solar power, CSP. CPV is a concentrator photovoltaic, right? Concentrating solar power, CSP, concentrator photovoltaic. Meter. This device can record the production of a photovoltaic energy at any time. Solar irradiance. Solar irradiance is the rate at which solar energy falls onto a surface. It's measured by both power and unit area and quoted as W per square meters, watts per square meter, solar irradiance. Grid parity. This is the moment at which the cost of solar becomes lower than that of a conventional energy form like coal, right? Grid parity. Coal versus solar energy, grid parity. Conversion efficiency. Conversion efficiency is the amount of available sun that can be converted into electricity throughout photovoltaics. Conversion efficiency. Direct current, DC. The DC is a current that has a single directional flow of energy starting in one place and ending in another. It's the current that powers a flashlight, for example. It's also the type of current that is generated by a solar panel. Alternating current, AC. Yeah, Edison was vehemently against the AC. The AC switches direction periodically, like 60 times per second, and is the form of electric power that is used by residences and offices. It's the current that's released when you plug something into the outlet in your home, for example. Rectifier. Rectifiers connect AC power to DC power. There are PSC, right? There are a few use cases for rectifiers, including channeling AC power into devices that use DC, like sensors or computers that control power generation. Rectifier. Since DC is a more efficient movement of energy, rectifiers can be used to transfer solar energy from one geography to another. The solar energy is converted back into AC on the other end when it's delivered to customers. DC is more efficient movement of energy. Rectifiers can be used to transfer solar energy from one geography to another. Inverter. Used in grid-connected solar power systems, the inverter converts direct current DC into an alternating current AC. Microinverter. These are smaller inverters attached to individual solar panels, optimizing energy production for each solar panel. Microinverter, right? Microinverter. Instant light. Instant light is the light that shines onto a solar panel. Angle of instance. This is the angle between an object's surface and the direction of sunshine. The maximum amount of energy is produced when the surface of a solar panel is exactly perpendicular to the direction of the sunlight. Some technologies help adjust the position of panels to match with the angle of the sun in the sky. However, studies have shown that this is not always the most efficient method of capturing solar energy, and that it's smarter to simply build out more solar panels. Energy payback time. The amount of time required for an energy producing system or device to produce the same amount of energy that was required to manufacture it. Most solar electric panels take 16 to 20 months to achieve this. Energy payback time, grid parity, right? Solar versus coal, for example. Grid parity, energy, we say a break-even point, but it says energy payback time, energy payback time, energy payback time, energy payback time. If you aren't already a client, sign up for a free trial to learn more about our platform. Yes, I'm interested, but later on, you might also like advanced manufacturing in 8 charts. 2023, the satellite and geospatial tech market map, which insurance giants have the most AI innovation. Our AI readiness index shows Cigna is leading the pack. So from this article, we learned many things and many expressions such as dangun, right? Such expressions. cbinsights.com, right? cbinsights.com. And this company is from New York. From this article, we learn such expressions as concentrator, photovoltaics, watts, hour, watt hours, kilowatt hours, energy payback time, grid parity, concentrator, right? Concentrator meters, and what else? Utilization, grade back, buyback. Photovoltaic, PPA, integral role, monocrystalline voltaic, polycrystalline voltaic. The shapes are different, right? Cell, module, panel, array. Let's see what kind of terms I missed or expressions that I found interesting. Standalone, right? Standalone system. Off-grid, feed in, right? Feed in FIT, right? Feed in tariff. Upstream solar, downstream solar. Financing, net metering, right? In front of the meter, behind the meter, gross metering. Front of the meter, behind the meter. Net metered, solar thermal versus solar photovoltaic. Brick, Adobe brick, thermal mass. Adobe brick, concrete and stone materials. Controlling energy bill, right? Energy bill, solar power overhauls into solar power. Stone and clay, building active solar systems, solar photovoltaics, power photovoltaic cells, solar cell, solar module, solar panel, array, monocrystalline solar cells rotated, right? It rotates. Polycrystalline has very poor efficiency because the inconsistency where the cells meet each other. Thin film PV cells, amorphous, right? Amorphous, very inefficient, very light. Solar thermal photovoltaic cells, TPV, multi-junction solar cells. Opening up more capacity. It opens up more capacity. It opens up more capacity. It opens up more capacity, right? Figures out the ideal. Yeah, that's it. Thanks for listening. Have a wonderful Sunday. Bye-bye.